Hello students, good evening. Can you see me and hear me? Am I audible and visible? Can anybody please confirm? Myself Shubhi Bansal. I'm a PMRF scholar from IIT Indore in the Department of Computer Science and Engineering. And today I'll be taking a live session on Natural Language Processing course by Professor Pawan Goel. So we'll wait for like 3 to 4 minutes for other students to join and then we will begin the session. Please wait. We'll begin soon. Okay, so let us begin. So today we'll be covering the concept of TF-IDF along with some numerical problems and how to do the coding of this concept using Python. So at any point any of you feels there is any doubt, please feel free to ask. I hope I am audible to all of you.
Yes, ma'am, you're audible.
Okay, great. Thanks for confirming. Are all of us familiar with the concept of TF-IDF? What does it stand for? TF-IDF. So what does TF mean here? TF is the term frequency. And what is IDF? IDF stands for the inverse document frequency. So today we will be covering some numericals on this. Before that, I want to, just revise this concept a bit so that we are comfortable when we are solving the numericals. So how do we represent it? So TF-IDF of a term T in a document D. So how will you calculate it? That is the multiplication of two terms, term frequency of term T in the document D into IDF of the term T. And can anybody tell, does this value remain the same for all corpus across different documents or does it change? This kind of
It
consecutive
will
questions can be asked. Does it remain the
it
same?
will be it will be changed, ma'am, depending upon the number of the documents and topics.
Actually, no, it does remain the same over the entire corpus for a given term.
For the that will be there. I thought for overall,
No,
like
no.
other also the
Say we are
it is okay.
considering the say we are considering a corpus of, say, Wikipedia articles. So how many times the term T, that is Sachin or some another term appears, that would remain the same. However,
Yeah,
across different
that is
documents,
true.
right? Across different
Yeah,
documents, like say one document is about World Cup 2011, another is about some IPL match. So there it can
yeah,
vary. The term T can vary, but the IDF value will remain the same, right? For Sachin,
yeah,
across different documents, across the
yeah.
Wikipedia corpus. Is it clear?
Yes, ma'am.
Okay. So this term TF-IDF is specific to a single document. These are important points that we should, kind of remember when we are solving. Just a second. Is there any doubt? Okay. I think just somebody left. It's fine. Okay.
Ma'am, have you shared the screen, ma'am?
Oh, is it not getting shared? Sorry.
No, ma'am. Screen is not visible, but your video is
Yeah,
visible.
yeah.
That's
So,
all.
so sorry. I'll just share it.
No
I've not
problem.
written much though.
Yeah.
Yeah. Can you see it now? Can you see it now?
Yes, ma'am. Now
Okay.
it is visible.
So I was saying that this TF-IDF, the overall term, this is a statistical measure. Why it is a statistical measure, we will cover that concept also. It is just a statistical measure and it is specific to a single document. However, this term, this value TF, it keeps on changing. But the IDF value, it remains the same. Okay. So this entire term is specific to a single document. This remains same over the entire corpus for a given term T. So in a sense, you could say it depends on the corpus, not on a document. Okay, it depends on the entire corpus for a particular document, and not on a. It depends on the corpus and not on a particular document, right? But then this TF term, it depends upon the count of the term within a document. Okay, so it can be asked like which term in the TF-IDF is dependent on the document and which is dependent on the corpus. So IDF is dependent on the entire corpus, but its value remains the same for different terms across the for a given term it will remain the same over the entire corpus, but this term frequency it keeps on changing. Okay, so what is this TF? How do you calculate TF? So that is number, this is nothing but the frequency of the term, how many times it appears. So number of times term T appears in document D upon what should be in the denominator. Since we are doing the frequency count, number of terms in the document D. Is that fine? Is that fine? So this stands for term count within the document. Now coming to IDF, how do you calculate it? So this is log or ln number of documents in the corpus that contain the particular term T, because we are calculating the IDF for a term T upon, so sorry, this will be in the denominator, number of documents in the corpus upon number of documents in which term T appears. Is that correct? So this is inverse frequency, inverse document frequency. So that is number of documents in which the term T appears upon, in the numerator will be the number of the documents in the corpus. Is that clear? So now let us apply these formulas to this question. Like I'll give the question, you just please try to solve it and then we will discuss how to do. So the first question goes like this. This is very simple question, just a formula based application. Consider a document that contains 100 words wherein the word cat appears 3 times. You have just one document that has 100 words and the word cat in that document appears 3 times. Now suppose in the corpus there are 10 million documents and the word cat appears in 1,000 of these documents. Okay, so you have to calculate TF-IDF of the word cat in the document D. Consider this is the document D. Okay, just a second, I'll just show the question. Just a second. I think somebody wants to join the call. Yes, please solve this question. Just apply this formula that we just discussed. Simple formula based question, and then we'll cover like little advanced questions on this. Always remember in IDF value you have to take the log of this term. Okay, please solve. Yes, please go ahead and solve this. We'll discuss in 2 to 3 minutes. And then we'll also cover like bag of words approach in TF-IDF, what is the difference, and these also from the how you can do the coding for these concepts. Please try to apply this formula to this numerical. We'll discuss in 2 to 3 minutes. So here just take that million is 10 power 6. 1 million is 10 power 6. Please type your answers in the chat box if you have solved. These kind of small numericals can be asked for 1 or 2 marks, either as a single question or a paragraph based question. As a paragraph based question also, we will cover one numerical today. So either please raise your hand or type your answer in the chat box when you have solved, so that I can discuss the solution with you. Okay, let us. Shall we solve? Or anybody of you needs more time? Please let me know. Okay, let us try to solve. So, the question says the word cat appears 3 times, right? And how many words are there in the document? 100. So, let us first calculate the term frequency of the cat in the document D. So, it says what number of times T appears in D upon number of terms in D. What is that? How many times the word cat appears in the document? How many times does it appear? 3 times. So we will say 3 upon how many terms are there in this document? It contains 100 words. So how many terms are there? 100. So the term frequency comes out to be 0.03. Now let us calculate the inverse document frequency for the term T. So how do we calculate that? That is the number of documents in the corpus, right? Just apply this formula. Number of documents in the corpus upon number of number of documents in which term T appears, that is cat here, in which the term cat appears. So how many documents are there in the corpus? Please interact and tell. Please unmute and tell. How many documents are there in the corpus? Anybody? 10 million? Is anybody there in the class? Please interact. We'll be able to learn much more efficiently. Okay, it is not visible again. I don't know, I think. stopped. So sorry for that. Is it visible now? Is it visible now? So do you want me to repeat some section or shall I continue? Hello. Okay, so do you want me to repeat some section or should I continue? Okay, I'll repeat. Okay, thanks for letting me know. I'll repeat. So I was saying, this is the question that we were given. The document has 100 words and the word cat appears 3 times. And now in the corpus you are having 10 million documents and the word cat appears in 1000 of these documents. Out of the 10 million documents, the word cat appears only in 1000 documents. So we were supposed to calculate the TF-IDF of the cat term in the document D. So this is the formula for calculating TF-IDF, where TF-IDF is the multiplication of two terms, that is the term frequency of the term T in the document D multiplied by the inverse document frequency of T. So how we are doing that? So term frequency of the cat in the document D is number of times T appears in D, that is the document, upon the total number of the terms or the words in the document. So in the question it is given that the cat appears 3 times and total number of words in this document is 100. So this becomes 3 by 100. Is this clear? Is this clear till this first part, term frequency? Then coming to IDF, that is the number of the documents in the corpus, that is given in the question to be 10 million. So that is 10 into 10 power 6 and we are supposed to take the log of it. In the formula it is log of it. So we are taking the log of this term, log of number of documents in the corpus divided by the number of the docs in which the term cat appears. So the word cat appears in 1000 of these documents. So in the denominator, what should I write? What should I be writing in the denominator? Okay. What should I write in the denominator? 1000, because the cat term appears in 1000 of these documents. So if I take the log to the base 10 of 10 power 7 by 10 power 3, so this is 10 power 4, and we know that in case of log 10 base 10, whatever the term is, it will come to the front and this term will become 1, log 10 base 10, so this becomes 4. Okay, so what does it become? The entire term becomes like TF-IDF of the term T in the document D is TF of the term T in the document D into the inverse document frequency of the term. So this is 3 by 100 into what is IDF value? IDF value comes out to be 4. So this is 0.12. Is it clear now? Is this point clear now? Okay. Is it clear now? How we have calculated the term frequency inverse document frequency, and this is just a statistical measure. Can you please explain IDF? Sure, I'll explain it again. So IDF, what is IDF? That is the inverse document frequency. What is frequent what is the formula for that? How many documents? Corpus is, you can consider the collection of the documents that you have. The entire set of the collection of the documents is the corpus. Say, like, you can say like a document is made up of multiple words, right? But the corpus is made up of multiple documents. So I can explain it this way. Suppose you have n documents, 1 2 3 up till n. These are your, this is D1, D2 and so on up till Dn. So these Dn, these form your entire corpus, okay? And in the document 1, you can have multiple words W1, W2, W3, W4 and so on till Wn. So you can say a word makes up multiple documents, and these documents, they make up the corpus. So if I am to represent in the terms of Venn diagram, it will be like word. It makes up the entire document, and this collection of documents is the corpus. Is this point clear? So in the inverse document frequency, what we are doing, how many documents are there? Because this is the inverse. So the entire number of documents comes in the numerator. And how many documents that contain that specific term T for which you want to calculate the inverse document frequency. So that will be number of documents in which the term cat appears. So in my question it was given that there are 10 million documents total. So I put it in the numerator, 10 million documents, and in how many documents the word cat appears? In 1,000 of them. So that comes in my denominator, and I'm supposed to take the log of it. So I took it to the log base 10. Sometimes you can take it to the log base 2, log base ln, natural logarithm. Mostly it is given in the question how you're supposed to take. So here I have taken it to the log base 10. This value inside becomes log of 10 power 7 upon 10 power 3. So this becomes log 10 power 4. So log of 10 power 7 upon 10 power 3. This is log of 10 power 4. And whatever term is there in the front, in case of log, whatever is there in the power that comes to the front. So this term comes out 4 log 10 base 10. So log 10 base 10 is 1. So this IDF comes out as 4, and the total term is the multiplication of these two. So 3 by 100 into 4, 0.12. Is it clear now? Is it clear now? Or shall I repeat? Is it clear? Dear student, is it clear? IDF part, how we have calculated? Okay, great.
Yes, ma'am, it's clear.
Okay, okay. Now let us proceed to one more question. This you please try to solve, and then we will discuss. Just please apply the same formula, but the question changes a bit. And then after this, we'll move to a little advanced numerical of TF-IDF. So, say in the question, you are given like this. Okay. So you have three documents, D1, D2, D3 in your corpus. So first document is a quick brown fox jumps over the lazy dog. What a fox. This is your first document. Second document is a quick brown fox jumps over the lazy fox. What a fox. Sorry, and the question goes like, how word fox is relevant to corpus D documents. So what is the question asking? Let me give you the hint. The question is asking you to calculate the TF-IDF of the word fox in your entire corpus. So you are to calculate the TF-IDF of the Fox in the first document, in the second document, and then you will see how is it relevant. So can you please try? Can you please try this? Just please try this question. I hope my screen is visible to you all. Okay. Please try. First calculate the TF-IDF of the Fox in the first document. Then you calculate the TF-IDF of the Fox in the second document. And then how to proceed further, I will explain. Please do this. So whenever it is given in the entire corpus, you have to calculate for all the documents separately. Please try solving. At least get the TF-IDF of the Fox in the first document. Similarly, do in the second document. So what is the term frequency of the word Fox in the first document? I am asking just the term frequency. How we will do that? Any idea, or should I solve? Just please let me know if you are solving, or should I directly solve? Please raise your hands. 2 by 12. Okay, good. Very good. Similarly, calculate for the second document also. TF of the word fox in the second document. And then I'll help in calculating IDF, and then how we will see how to calculate how the word fox is relevant to the corpus D documents. Please take 2 to 3 minutes more, then I'll discuss. Also try to calculate IDF. This is the formula if you can see my on my screen. Okay. IDF remains the same for different over the entire corpus for a given term. Here we will see how and why. So somebody is saying, no. So it is that is correct, but in the IDF, it should be log of 2 by 2. It should be log of, and log of 1 is what? Please correct. See, in the formula it is log of. I'll show you the formula again. It is log of. We have to take the log. See here, log you have to take. Other things are correct. So I think one of you is able to solve. So let me proceed ahead with the discussion. So I'll solve it here. So how many words are there in the first document? How we will calculate? See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here you should not see like that the word fox is repeating or the word is repeating. That you should not consider. You're not here to consider the unique words. You just see how many terms are there in the document D1. So that is 12. And in the second document, similar way. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, it turns out to be 12. So this is the cardinality of the terms in the second document. So how we are going to do this is first calculate the term frequency of the word fox in the first document. So that is number of times fox appears in D1 upon number of terms in D1, that is nothing but the cardinality of D1. So how many times the word fox appears in D1? How many times does it appear?
2 times.
2 times. 1 and 2. So we will write 2 by 12. That is 1 by 6. Similarly, you will do term frequency of the word fox in the document D2. That is number of times fox appears in D2 upon cardinality of D2, right? So that is how many times the word fox appears in D2? 1, 2, 3. So numerator is 3. But the cardinality of D2 is what? It is again 12. So 3 by 12, that is 1 by 4. Is it correct? This value comes out as 0.17. This comes out as 0.25. Now let us calculate the IDF of the term fox over the entire corpus D. So that is number of documents in the corpus D. That is, D is the collection of D1 and D2 here, upon number of documents in which the term fox appears. So how many documents are there in the corpus? 2. And you have to take the log of it. Always remember to take the log of it. So log of how many documents are there in the corpus? 2. In how many documents the word fox appears? The word fox appears in both of them. So log of 2 by 2. So this is log of 1, and log of 1 we know is 0. So now so now what we are going to do is TF-IDF of the word fox in D1, that is the term frequency of the fox in D1 into IDF of fox. So that value is, in the first corpus, in the first document, what was the term frequency? 0.17, and IDF value came out to be 0, so it is 0. And the TF-IDF for the word fox in the second document, what it will be, again the multiplication of term frequency of fox in D2 into inverse document frequency of the fox over the entire corpus. This term remains the same again. So term frequency in the second document is what? 0.25, second document. So this is 0.25 into 0. Again it comes out to be 0. So now the question asked you how the word fox is relevant to the corpus D documents. Always remember, if the TF-IDF value for a term T comes out same for a particular word in both the documents, here it came out as 0. So you will write the word fox is equally relevant to the corpus D documents. Why? Because TF-IDF for fox in D1 and TF-IDF value for fox in D2 is same. Does not matter if it is 0. What matters is whether that value is same or not. If it is same, then that term is equivalent, equally relevant to all the documents in a particular corpus. Is it clear? Is it clear? So from here we can understand one thing, that TF is a simple choice. TF is your term frequency, that is a simple choice. That is raw count of a term in a document. But your IDF, see, the word fox is appearing so many times. That means that word is not so important. Like there are stop words in English language: are, is, am, I, he, she. They appear multiple times, but they do not hold significant meaning. So that is why we are trying to lower their weightage. The terms that are appearing too frequently, they are not holding much information. So how do we lower the weightage of the terms that appear too frequently is by IDF. So IDF is used to measure the importance or the meaning of the terms that appear less frequently, so that it can account which terms are more important, which terms hold more meaning. So that is why this measure came into account. So IDF measures how much information the word provides in our entire corpus. That is why its value remains same for a particular term over the entire corpus, because how much information this word is providing. So, and TF-IDF is, since it is the multiplication of these two, it is just a statistical measurement. Why statistical? Because it is not taking the order of the words in which the words are appearing, right? The word fox, it is just taking how many times the word fox appears, either in the entire document or over across different documents. It is not taking the sequence into account, like the word fox appears before quick, after quick, before the word dog or after dog. But if you see in our English or in our natural language, the sequence is equally important. But then this TF-IDF measure does not take the order or the sequence of the words into account. That is why we call it as a statistical measure and not a semantic measure. Semantic is if it is holding any, if it is taking into account the meaning of the word. It is taking into account how important that word will be, but it is not taking into account the meaning. So say there is this word bank. So one bank can be the money bank in which we deposit the money, right? Another bank could be like the bank of a river. But when you are calculating in terms of TF-IDF, will it take their meaning into account? No, it will just see that this word bank appears two times, or in what context is it appearing. Like if the word, if I say Ram went to bank for a walk, so and then he withdrew money from the bank. So if you follow the words in this sentence, you will be able to understand that the first bank stands for the bank of the river where he is going for a for relaxation, and then in the second, the second bank is where he goes to deposit or withdraw the money, right? But if you do not take this sequence of words into account, you will not be able to understand the meaning or anything, right? So this is just a statistical measure. It does not take the order or the sequence of the words that comprise your document or your corpus into account. Okay, I hope it is clear. So let us do one more question, and then we will proceed to see how we can do Python programming for bag of words and TF-IDF. So the third question goes like this. You have again two documents. Just to see whether you understood and can apply the concept or not. The man went out for a walk. The children sat around the fire. Now, can you calculate the term frequency TF-IDF of the word the across the entire corpus? TF-IDF of fire and TF-IDF of children. Please do these three questions. These kind of paragraph based questions can be asked. Please try to solve. Once you have solved, please put your answers in the chat box so that I can know when I should discuss. All of you, please try to solve. We've covered two examples already, so I think you should be able to solve now. Mhm. That's correct. For B, it will not be 1. So let us see how to do for B. So calculating the term frequency TF of the across D1. So that is, how many terms are there? 1, 2, 3, 4, 5, 6, 7. That is 1 by 7. And term frequency of the in D2. That is 1, 2, 2 by 1, 2,
By
3,
six.
4, 5, 6. Yeah, that is 1 by 3. Now IDF we should calculate for the across this corpus. How many documents are there in this corpus? 2.
2.
And how many of them contain the word the? 2. So this is 1,
2.
0. So if you multiply TF IDF for the first document will also be 0, for second document will also be 0. So this TF IDF value comes out 0 here. That is correct. I hope all of you are able to do this. But now for fire, how we are going to do? See, the term frequency, for fire across G1. How many times it appears in the first document? It does not appear in the first document, first of all. So term frequency will be 0, because of which the entire terms become 0. Term frequency of fire in document D2. That is, it appears one time. And how many terms were there? 6. And now IDF of fire across this corpus D. That is log of how many documents are there in the corpus? 2. How many of them contains the word fire? 1. So this is log
1.
2. And if you calculate TF-IDF of fire across D1, it will be 0 because of the multiplication 0 into log 2. But the TF-IDF value for fire across D2, what it will be? 1 by 6 into log 2. Is that correct? That is not 1, right? I hope it is clear.
Ma'am, what is the log base value here?
So I hope in the question it will be given, but log 2 is mostly 0.3010, right?
Yeah, if we take the log base
Yes,
10.
right? Log 10 log 2 base 10, right? And if you take the natural log, it will be different, right? So when you're solving,
Okay, I
according to
missed
the
the
options, you can see,
idea.
yeah, according to the options, you can see whether you have to take log 10, log 2 base 10 or natural log. The answers will be according to that, right? So similarly, you can do for the third part also. The answer I think would come out the same. 1 by 6 into log
Yes,
2,
ma'am.
right? So this is 1 by 6 into log 2. 1 by 6 into log 2. Now, let us do one more question, that is as a bag of words example. So that when I am explaining the Python program, it will be clear to you why the particular value is coming out in that fashion. So say we have three reviews. The first review is, this movie is very scary and long. Okay. Second review is about the same movie. This movie is not scary and is slow. The third review says, this movie is spooky and good. Okay. Now, you know what the bag of words representation is? Do all of you know what the bag of words representation is? So I'll give you a hint and then you please try to draw the bag of words vector for all the three reviews. So first of all, you build a vocabulary. Vocabulary is unique words from all documents. Okay? And then how many times that word appears in a particular document or over the entire corpus, you update the count. Okay? And then you try to write the vector for it. Can you please try? At least please tell me how many unique words are there in this across these three reviews. Please help me to derive the bag of words representation. Count and tell.
11.
11, right? Correct. So now I'll write it here only how we will calculate it. In case you are feeling stuck or you're not understanding, please feel free to ask. I'll explain again. So first of all, when we are writing the vocabulary, just do it like this. Okay. Will the space be sufficient? Okay, yeah, I think we'll move to the next one. So just write R1, R2, R3, and then all the unique words that are there in the columns. This movie is very scary and long. This movie is very scary and long. What did the other review say? Not. Now, what words are unique to this review that you write? This movie has appeared already, is also appeared. Not. Scary and is they appears. Not and slow, right? So you write these two now. Not. Slow. Now from next review, what you will write? Spooky, good, right? Because all others appeared already. So you write spooky and you write good. Is this point clear till here? That you just have to pick the unique words. Okay? Okay, so let us see now how to derive the bag of words representation. So now whichever word appears in whichever document, there you will write 1, else you will write 0. And if a particular word is getting repeated in a particular document, you just update the count of it. So now tell me for the first review how you will write. What did the first review say? Let us write what was the first review. What was the first review? This movie is very scary and long. Now, in place of this, you put 1 because this appeared in the first review. Movie, what we will write? 1 or 0?
1.
Is 1 very scary and long? Till this point, you will write once. Now, did not appear in the first review? Did the word not appear in the first review? Let us have a look. Did it appear? Yes or no? It did not appear. So what we should write here? 0 or 1? What should I write here?
What should I write here?
0 or 1?
Zero.
0. Slow 0, spooky 0, good 0. Now for the second review. What does it say? This movie is not. चलो यहाँ तक लिख. This movie is not. Wherever the words are appearing, just write one. Not scary. And is appearing two times, so you just update the count. Is slow. Now the words that didn't appear in those places, you write 0. Okay. Now can you write for the third review and tell me what does your vector come out? This movie is spooky and good. So what should I write? This movie is spooky and good. Other places 0. So now if somebody asks you what is the vector representation, bag of words vector representation for R1, you just write this vector that you got. 1 1 1 1 1 1 1 0 0 0 0. Similarly for R2, what it will be? 1 1 2 0 1 1 0 1 1 0 0. And for R3, what it will be? 1 1 1 0 0 1. Zero 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 1 1. Is it clear? So now tell me, do you see there is any advantage of this representation, bag of words? What do you think is the can be a disadvantage of this technique? Any idea? What do you think? Any one of you? What do you think is the disadvantage? Any idea? How many students are there? What are the
I think if corpus is long
uh-huh.
or lengthy, then it will be complex.
Yes, very correct. Very good observation. So if the corpus is big, then you will have large number of unique words, right? And then for how many words you will keep on doing this exercise 1 1 1 0 0. And if it is very big and the words are not that repeating that frequently, then the matrix will this vector representation will have lots of zeros, right? So we call it as a sparse vector representation. And the vocabulary is one very big issue, so that is why we say this is not an efficient approach. Compared to this, TF-IDF is a better approach, right? Is it right? Why? Because then it will help you to calculate what is the the TF-IDF value of this of the word this, and how much importance it is providing to the entire corpus. So TF-IDF is a far better approach as compared to the back of the words representation. Okay, now let us see these two concepts from the Python point of view. Do you want to calculate the TF-IDF values for this corpus? Will you be able to do, or you want me to calculate? I think you should just try it once. If you're not able to do, then just let me know. As of now, we will proceed to the Python programming for TF-IDF and bag of words representation. Okay, so I hope my screen is visible to all of you. So to do this kind of exercise, that is the bag of the words representation, what we will do from the sklearn, that is one library in Python, it already has this inbuilt feature and it goes by the name count vectorizer. So vectorize is converting the numbers into the converting the words in the form of numbers, and how we are converting, that is based on the vocabulary size. And in sklearn dot feature extraction dot text has this package count vectorizer, using which you can build the bag of words vector. Okay, so what we are doing, we are just creating an instance of this count vectorizer function. Okay, then now we are creating the documents for which we want to obtain the bag of the words vector. Say here we took these three documents. Okay, and I am taking them in the form of the numpy array, and then when I do bag is equals to vectorizer, vectorizer was containing your count vectorizer, that we just saw how we compute the count vector in this slide. I just explained how we compute the same functionality will be performed by count vectorizer. Okay, so what it will do, and this dot fit underscore transform is used to obtain this vector for the particular documents that are there in your corpus. And then when you print vectorizer dot get underscore feature underscore names underscore out, you will be able to get these kind of vectors. If you can see my output, okay, let me reconnect and show. So first of all, I am printing the unique vocabulary, how many unique words are there in my corpus. Okay, and then it is also assigning if you see here, it is assigning it the vectors in this way, and this is your unique vocabulary. And then we are printing the indices. This is not to be taken into account, this is just for my reference. So this is the unique vocabulary that we are getting, and this is the bag of the words representation. Okay, now if we want to do the same example for the sentences that we took, let me write those sentences. What were those sentences? And let us check whether we got the same output or not. This movie is very scary and long. Second review was, this movie is not scary and is slow. This movie is not scary and is slow. What was the third review? This movie is spooky and good. This movie is spooky and good. Let us see how many words in the vocabulary we are getting. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, actually, why we are getting lesser words is, if you see, we are not getting any less. Just a second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So let us check whether we got the same vector or not. I mean, this can also vary based on how it has listed its vocabulary, right? Okay, good. So it is 1020. Let us check for the second review. So I think maybe the way it is assigning indices to it, it is the order is a bit different. But I hope you did understand the concept how we can apply this count vectorizer and get the bag of the words representation. Is it clear? So this numerical feature vector that you are getting for your inputted document is the bag of the words representation for this document. And this the size of this vector depends on how many unique words are there in the vocabulary. Any doubts? Any doubts here? Do you want me to explain this again? Any doubts here? Or do you want me to explain this again? So I'll try to explain it again once. So there is this one library, scikit-learn, that goes by the name sklearn in Python. What we are doing this these are the features how we can represent our different documents. So this module is there, sklearn, and in that dot feature underscore extraction dot text you are importing this count vectorizer that will help you to compute the bag of the words representation. So how does it go? Like, we are creating an instance of it, a vectorizer. We have created an object, and the entire functionality of this package will be stored in this vectorizer object. And then this vectorizer object you are going to call on your corpus of documents. The corpus of the documents we are going to take in the form of the numpy arrays. That is, we are if we are taking three documents here, that we are taking in the form of the numpy array. And what I am going to do to get their bag of words representation, the vectorizer, count vectorizer, from count vectorizer I created this object vectorizer. So I'm going to do dot fit underscore transform, and what I want to transform is this documents, the corpus that I want to input to the model, that I want to transform. So after transformation, it will be stored here in the bag, that is we have just fit it. Now, to get all the unique features or the unique words or the unique tokens, that is the vocabulary, what I am going to do, print vectorizer dot get underscore feature underscore names underscore out. This is one function to get the unique words or the vocabulary from your corpus. Now we are going to associate each word with a unique index, because you cannot represent the word the directly, right? So you will map each word to a particular index. How it does is, these kind of the models, they have already been trained on a very large data. So depending on how they have been trained, they assign them these random numbers. They appear random to us, but actually they are not random. So you can just as of now just forget this and just focus on how we are getting excuse me, sorry, how we are getting the bag of the words representation for different sentences here. That depends on how many unique words are there in your vocabulary. See, the word 2021, does it appear in the first document? Let us see. This is your first document. Mirabai has won a silver medal weightlifting Olympics 2021. Since 2021 appeared, so it assigned a 1 to every word that appears in the document. It will assign 1. The word that does not appear, it will assign a 0. And if a particular word is repeating, so I think here this word repeated, which word? 1 2 3 4 5 6 7 8 9 3 4 5 6 7 8 9. The word in is repeating 2 times. Let us see. Mirabai has won a silver medal in. So if the word in is repeating, the number of time it repeats, that count you will update, and that is how you get this vector representation. I hope it is clear now. Any doubts? Any doubts till this point? So the count vectorizer helps you to obtain the bag of the words representation. So is it clear to all of you? Okay, great. Now let us move to the, just a second. Now let us move to the how we can calculate the TF-IDF values using Python code. Okay. Can just skip this part. Yeah. So how to calculate the TF-IDF values? See, if we are giving okay, in this example, I have tried to demonstrate both TF, IDF and count vectorizer, that is the bag of the words representation. But additionally, I have done one thing. I have removed the stop words. So let us see how we can do it. So do you want me to explain them separately, or explaining both of them in one code is fine for you? Because I think word count vectorizer is already clear. So shall I proceed in the same manner? Okay, so see, like the way you imported, just give me a minute. Yeah. So, from sklearn.feature underscore extraction, initially we had imported the count vectorizer. Similarly, similarly, you can also import the TF-IDF vectorizer that will help you to compute the TF-IDF values for different terms that appear in your corpus. Okay. So from sklearn.feature underscore extraction dot text, I have imported this TF-IDF vectorizer, and I have taken some set of documents, and I'm going to apply the same thing. But before applying, what I'm going to do, I'm just removing the stop words. Stop words are those words that appear very frequent in our corpus, and they do not add significant meaning to it. So here, can you tell me in the first document what can be the stop words? What do you think can be the stop words in the first document of the train set?
H
Is and
dot
is, yeah,
dot
dot is a punctuation symbol. So we are talking about the stop words. The and is, right?
the is
Yeah. And in here, it can be we, can, right? The, all the verbs, right? Like the helping verbs, not actual verbs, because C is important here. That is also a verb, but the helping verbs, right? So that can also be removed. So if you see what I am doing, I have just called the list of the stop words from the TF-IDF vectorizer. See, first of all, I'm going to do what? Like we did here. Like we created this object vectorizer from count vectorizer. Same way I'm doing here. TF-IDF vectorizer. And if you want, you can pass it normally. If you pass it like this, see. If you pass this like this empty, then it will not remove the stop words. Okay, it does not remove the stop words. But if you pass it like this, that you are telling the model that you should analyze what all stop words are there, and I am writing the text in English language, so I have specified the language, so it will remove the stop words if it encounters. Okay, then what we are doing, we are doing the same thing as we did above. For the object that we created, we are doing dot fit underscore transform, and what we are transforming, the training set of the documents. Okay, Then what I'm going to do, since I want to convert them into the features, so I am doing dot get underscore feature underscore names underscore out, and these are the TF-IDF tokens that I am going to get. And then I will this is just to print their values in the data frame format. Okay, so if you also calculate it manually, these are the values that will come out. So is this point clear to all of you? And if you wanted to analyze it using the count vectorizer, then this is the how it should appear. So any doubts to anybody how we have done the TF-IDF vectorization?
So in this first we have removed the stop word and then count the unique words
Yes,
like
yes,
this.
yes. But if you want to do the same exercise, you do not want to remove the stop words, you want to get the TF-IDF values for them also. So how we can do? Let me just modify the code and show. Here. This will not, I hope it does not remove the stop words in this scenario. Let us check. So can you see it does not remove the stop words now, because now you are getting the TF-IDF values for the is everything, right? But you see the TF, is it clear now? Both ways we have done, removing the stop words and not removing the stop words. Is it clear?
Ma'am, would you show the result of this
Sorry.
without and with?
Yeah, that will
The
vary, right?
result of
That will vary, because you see what is the in the doc one, what does the TF-IDF value come out for blue? That is 0.707. And what does it come out here? Because you see in the TF term itself, right, the denominator will vary, है ना? Number of terms in document D, right? Is it right?
so this can be do in the bag of word also, means we can remove the stop words in the bag of word also.
Yes, you see here, when I have given it like this, I did it, maybe I'll explain it again. Here when I have passed it like this, right, I have passed that analyze all the stop words and then you remove them. So count in the count vectorizer we are doing, right? When I have passed it the stop words list, then it has not printed the is, right. But in the second code snippet, when I have passed the
Yes, ma'am.
braces, I have not passed anything in it, then it is printing for the and is as well, right? Is it okay?
Yes, ma'am.
Yeah, okay, thank you. Any other
Yeah.
doubts, anybody? Please feel free to ask. Any
So,
doubt?
ma'am, these count vectorizer is here bag of word.
Yes, this is bag of words representation. This is how you are,
Okay.
when you are doing the coding in Python, then this is the set of the libraries how you will use and invoke. Okay, so the names may not be the same, but the functionality goes by that name, right? Actually, this is the name of the package and the
Yeah.
tools that will help you to compute the bag of the words representation. If you calculate it manually, it will come out the same. Is that okay? Does that answer your question?
Yes, ma'am. But ma'am, what is the difference then TF, IDF, and the count vectorize? Means we are following the following the same process
No,
like
no, no. See, that is
means
the
it
entire
can
concept
also
of
be
term.
lengthy na.
Sorry, can you not see
It
the?
can also be lengthy na because
Yeah, it is
as
lengthy,
the
but then
values in between the
see. Let me help you with this. In the bag of the words representation, this entire thing you will take as the feature vector, right? For the first document. But when you are doing, and this is not adding any additional information to you, right? This is just the number raw count it is giving. But then how does TF-IDF help? Though it is also a very big vector and it will also depend on the vocabulary size, but then it does give you the understanding how much importance every term carries, what meaning it adds to the entire corpus. That way it is different, not in terms of the vocabulary and other things. Okay, that vocabulary limitation is there with both these
okay
approaches.
means
Hello.
okay so that means from the count factor I yes ma'am I'm
Yes,
audible.
yes, you are audible. Please continue what you are saying.
So that means in count vectorization, we can also only check the count is it comes in the
Corpus or not,
document or not.
or how many times
But
it is
in
coming.
yeah,
But then
okay,
TF-IDF
and
gives
in
you a
the
statistical
TF,
measure, right? How important a particular word is. And it is by itself eliminating the importance of the stop words, right? If you see, for the first document and the second document, the value of TF-IDF for the word is same. That means it is equally relevant, or it does not hold any meaning in the entire document, right? But the sky term in the first document, the sun term in the second document, they are having much more importance, right? We discussed this point na, that if TF-IDF value is same,
yeah, ma'am.
then it is equally
Yeah, ma'am.
relevant. If it is equally relevant, that means it does not have much importance, right? Is it okay?
Okay, fine, ma'am.
Okay. Any
Yeah,
other doubts
fine.
to anyone else? Please feel free to ask the doubts. Any doubts in this Python code? If not, then we can proceed ahead. Okay. Okay, just give me a minute. I'll just be back. Give me a minute. So, madam, what will be the pattern of question? Is there coding parts or not? No, coding parts will not be there. This is for your understanding how we can code the concepts that we are learning using Python. In the beginning, first part of the lecture, I how much percentage? Yeah, the first half of the session that I did, all those kind of questions will be covered. So I hope that answers the question. This is because some of the students they are interested in learning, so that is why I am covering the concept from the programming point of view. See the benefits of these internal assignments. So yes, I think the questions numericals that we did in the first half, that that would have questions related to what we did, related to TF-IDF. So that is up to you. You can decide whether the benefits are there or not. Okay. So moving forward, in the last session, some of you had requested me to cover the similarity calculation using BERT model, right? So, so if we see how we can cover the Jacquard similarity, does any one of you remember what is the formula for the Jacquard similarity? I think we did one example, numerical. So, what is the formula for the Jacquard similarity? What is the formula for the Jacquard similarity between two sentences?
A intersection B upon absolute of A plus absolute of B. I think
A
so.
union B, right? Absolute of A plus absolute of B is in the dice coefficient, right? In the numerator, in the dice coefficient, it
Okay.
is, you remember, I think you were there in the last session that we did on last Tuesday. So that was 2 times A intersection B cardinality of A plus cardinality of B, right? This is very important. Please take a note of this.
Okay.
है ना? Okay. So so how we can do the same using Python code is like this. We just split the set by sentence by tokens, and then you apply the set operations. Why we are applying the set operations? Because we only want to take the unique words into account, right? So first we are computing the intersection, that is the numerator part of the Jacquard similarity, and then the denominator part, that is the union, set 1 union set 2. And then what you will return is length. Why we are returning the length? Because in the formula it is like cardinality of A intersection B upon cardinality of A union B, right? So that is, you are return the length of the intersection set upon the length of the union set. So say if you are having two sentences like the cat sat on the mat and the kitten rested on the rug, can you try to compute the Jacquard similarity for these sentences? So sentence 1 goes like, the cat sat on the mat. Let us see if the value comes out to be same or not, because someone is asking like what is the value of this assignment that I am doing. This will help you to validate how the concepts we are learning. The kitten rested on the rug. kitten rested on the rug. Can you compute the Jacquard similarity assuming that this is sentence A and this is sentence B? Only take the unique words from here into account. From here, Jacquard similarity should be. Writing the formula, just let me know what does the value come out as. A intersection B upon cardinality of A union B.
2 by 8.
Let us see. So what are the common words here? The kitten rested on the rug. On.
On.
Anything else? Cat is not there, sat is not there, mat is not there. So how many common? Two. And how many words we have in the union? So the union will have the cat sat on mat, kitten rested rug. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. So 2 by 8, 1 by 4, 0.25, right? These kind of questions can be asked. What is the Jacquard similarity between the two sentences? What is the dice coefficient? So let us see, what does this say? It says 0.33. Let us see why. This does not satisfy. What are we missing?
It has taken the two times what,
Just a
but it is
second.
not unique.
Yeah. Yes, just let me check once. If we do not take it two times, then does it remain the same or different? Let us see. So it is getting repeated how many times? 2, 3. So it will be 3 by 8. If we take the into account,
I think they have taken 3 by 8.
yeah, then this should also change. Just a second. Let us see. Then rested on the rug. So 3 by 8, does it come out as 0.33? That also does
But
not come out.
the
Then
is
the
the
denominator.
should be taken one.
Sorry? Sorry?
The is not. We have taken the unique word one time, no? So the is repeating the once again. So we have
Yeah.
only. But in the programming, they have taken two times for the unique word.
So you see here, then the denominator will also change. Why? Because the cat sat on the mat, right? That is appearing two times. The kitten rested on the rug. Then it will be 1 by 3 and then 0.33. Let us check just a second.
So first we have taken if the unique word we calculate the unique word, then I think it will take that the only one time.
Mhm. Let us print and check. So see, it is taking it twice, three times, right? The on the. And in the denominator, it is taking sat on rug, rested mat, kitten, cat, the. It is taking it twice. I think what it is doing is it is taking this capital THE and the small THE as different words, right? You see here?
Ma'am, could you do both the term like similar?
Yeah.
Use capital in the
So
second
for that, what
occurrences.
we can do
That,
is, see, what we can do in that case is set 1 is equals to, for that, first of all, we should write like this. S1 is equals to S1 dot lower. That will not treat capital THE and small THE as different. I think so. This should work. Now it works, right? Understood?
yeah.
Understood, right? It was treating the
Yes, ma'am.
capital the and small the, because it is a it is taking them as different words. It is case sensitive, no? It is treating them as separate words. That's why we were getting it as different. But if you convert it into the lower case, then you get the correct answer like 0.25. Okay, clear?
So ma'am, in the exam,
Mm-hmm.
it can be differ na means if we taken like the pauses, we have taken only the unique words and they consider the like this programming, so it answer can be wrong.
So I
So
would
how
still
can we
suggest
justify?
the better answer would be 0.25 only, right?
Okay, ma'am.
Okay. But if there is anything, then I think if someone takes it from this perspective, treating the capital THE and small THE is different, then the weightage should be, he can be given benefit of doubt, right? Because that is also correct. We just saw that the computer gives like that only, है ना? If we remove these two sentences, right? So I think both of
Okay.
them are acceptable, but much suitable answer is 0.25. Okay, clear?
Yeah,
So,
ma'am. But ma'am, such type of conspiracy occurs in the assignment. I think the question was in parse tree.
mm-hmm.
The at least one of probability and the most probabilities. I don't remember the assignment number 6, I think.
Mm-hmm.
So such type of ambiguities can occur with us, so we can stuck in this type of questions.
Sorry, I didn't
However,
get
we
your
know the
point.
answer
Could you
for.
please repeat?
Actually, ma'am, this type of questions can occur ambiguity, just like
Mm-hmm.
one ambiguities occur. Uh, Misunderstanding occurs in the assignment number, I think 6, not exactly remember,
Mm-hmm.
where we have to find the at least one of the probability.
Yes.
So, but they have given the union of two probabilities. The answer, however, we know the answer for this. So, what will be the union for these two, and the what will be the answer for the at least one of the probabilities? So,
That,
sometimes
that's why I'm saying if there are any such questions,
it
then the committee decides accordingly who should be given weightage to, right? That is not in our hands. We can only tell the correct procedure to solve
yeah,
it.
ma'am, but
But then, if you see, most of the times, if there are any such questions, even in the competitive exams like GATE or JEE, then every student gets marks, right? That is not deliberately they are deducting somebody's marks. If this is the scenario, then both 0.33 and 0.25 will be treated as correct, right? But then again and again, I am saying more suitable answer is 0.25. Okay? Benefit of doubt, that term is there, no?
okay, ma'am.
Okay.
Yeah, but from this we can lose our marks now.
No, no. You just try to do your best case scenario and leave the rest. Just go according to the concepts that are being taught in the video lectures and how we are solving them in the numericals, how we are helping you to solve the numericals. I already said 0.25 is a more correct approach, because if when you are taking the sets into account, you just treat the unique words, right? You are not taking their cases into account. The program does take, right? So if someone is doing from
Okay,
that
ma'am.
perspective, he is also correct only, because the computer validates that, right?
Ma'am, what about the week 9?
So I'm going to take it on Tuesday, don't worry.
Okay, okay. And ma'am, there's some doubt in the week 8. Actually, we have done the question that we have, I think we have discussed on the week 8 assignment, week 8 in the last session.
Yes, please tell me what is the doubt.
Actually, ma'am, we have done the assignment and the question was there. We have to calculate the Leacock similarity between the house and door, and that was based on the path length.
Acha, okay.
So, so they were
What
given the
question from
wrong
week 8?
assessment.
Just let me see. Just let me see.
Yeah,
So, yeah, which question? Week 8?
ma'am, Leacock similarity. I think last seventh question. I think so.
Mm-hmm. Leacock-Chaudhary similarity. Okay. Maybe I'll cover this concept on Tuesday.
Yes, ma'am. Yes,
Okay.
ma'am. But the answer, the we have solved the answer,
Mm-hmm.
and the answer is not mentioned in the options. So I tick the none of the above.
Mm-hmm.
But they have incorrected evaluation and they given the answer of 0.398. That is in the option.
So in this case,
So
can you please mail to the support team, NPTEL support team, or you could post it on the on the portal about this specific question. I'll also try to get in touch
yes,
with them.
ma'am. Yes, ma'am.
Okay.
I did the same procedure,
Yes. Yes.
but I want to know the exact solution from
Yeah.
your side
Yeah.
also.
Sure. I'll take it up on Tuesday, because I think we are reaching the closing time today. I'll definitely take it up on this Tuesday. Okay.
Okay, ma'am. Okay, thank
Yes,
you.
sir. Roshan sir, may I please know your query? Roshan sir, are you there? Hello? Hello? Can you hear me, sir? Actually, I'm not getting your question. As I already said, I try to. Okay, I think you already left. Okay. So I hope all of you are comfortable with the Python programming that I am doing, or is it not comfortable?
Actually, ma'am, this time we have to focus on the main exam, and I am very worried about the main examination.
Okay.
How much portion will come in the final exam from this session? Actually, we have not go through the search lectures. The
That is
Professor
that is
Pavan
very
Goyal's.
important. You should
I have already.
go through sir's lecture. That is very important, actually.
Actually, ma'am, uh, what do you think? I don't know. Actually, I'm not understanding the actual point from them side. I can understand whatever you are discussing and the other PMRF discussing. The live interaction is good. So if there is any query, we can ask. But I have not found so much profitable from the lectures, or maybe this is my error. For my error, I am not understanding the language of that professors.
Okay, okay.
Maybe. So just I'm asking how much can we cover from this assignments
I think most of the questions can be covered, but to
that
solve
we
these
have done
assignments,
up to.
but please understand that to solve these assignments, it is very important that you watch the lectures. The questions can be clear, concepts can be cleared from that, and then you can apply these concepts to these questions. So I would highly encourage you to please go through sir's lecture. It is highly recommended. Okay, please try, because if you're not understanding a certain concept, we can definitely take it up. If you see in each of my live sessions, I first try to cover the concept and then I discuss the numerical, right? So if you see the lecture and if you're not understanding, then you can let any of the TAs know, and then we can cover it. But please, I would say, please do not skip those lectures. That will improve your understanding of the concept. Rest is up to you.
Actually, ma'am, there is so much stuff.
Yeah, that is there, I understand. So I think, please decide according
Yeah,
to whatever feels okay. Okay, okay. And I'll take that Leacock
yeah.
auto
Thank you, ma'am.
similarity in the session on Tuesday. Please do join for discussion on that. Okay. Okay, thank you for joining.
Yeah, ma'am. Okay.
Thank you.